Picture this. It's September 1942. A US Navy test pilot is about to do something absolutely insane. He's climbing into the cockpit of America's most feared enemy, the Japanese Zero fighter, the same aircraft that dominated the skies at Pearl Harbor, the same plane that was shooting down American pilots left and right across the Pacific. But here's the crazy part. This Zero isn't in Japanese hands anymore. It's sitting on a runway in San Diego, California. And this American pilot, he's about to become the first person outside of Japan to fly it. His palms are sweating. The instrument panel is in Japanese. Everything feels foreign. But in the next 60 minutes, this single test flight is going to expose weaknesses that will doom Japan's aerial supremacy. The secrets he discovers will help create a weapon that shoots down over 5,000 enemy aircraft. And it all started 5 months earlier on a remote island in Alaska, where a 19-year-old Japanese pilot made a mistake that would change the entire war. This is the story of the most valuable aircraft capture in military history. September 20th, 1942, Naval Air Station, North Island, San Diego, California. Lieutenant Commander Eddie Sanders gripped the control stick of the Mitsubishi A6M2 Zero fighter. Beyond the windscreen, armed guards surrounded the hangar. Their orders had been clear since this precious cargo arrived 3 weeks earlier. This was the most valuable aircraft in the world. Sanders released the brakes, and the Zero rolled forward, its engine purring with surprising smoothness. Within minutes, this test flight would transform American fighter tactics forever. But to understand how this captured Zero ended up in American hands, we need to rewind the clock. June 4th, 1942. While American dive bombers were destroying 4 Japanese aircraft carriers at the Battle of Midway, a smaller drama was unfolding in the Aleutian Islands of Alaska that would prove equally transformative. 19-year-old, Flight Petty Officer First Class Tadayoshi, Koga launched his Zero fighter from the carrier Ryujo, part of a diversionary strike against the American base at Dutch Harbor. The morning mission went according to plan initially. Koga and his wingmen attacked Dutch Harbor with devastating effect, shooting down an American PBY Catalina patrol bomber. The Zero performed exactly as designed, faster and more maneuverable than anything the Americans could field. Then a single bullet changed everything. Ground fire from Dutch Harbor struck Koga's aircraft, severing the oil return line. In an engine dependent on precise lubrication, this was a death sentence. Oil began spraying from the damaged line. Koga knew he had perhaps 15 minutes before the engine seized completely. He radioed his flight commander about the damage and turned toward Akutan Island, 25 miles east of Dutch Harbor. Japanese planners had designated it as an emergency landing site, with a submarine waiting offshore to rescue downed pilots. As Koga approached Akutan Island, he spotted what appeared to be a perfect emergency landing field. A long stretch of flat grassland half a mile inland from Broad Bight. His wingman circled above as Koga made his approach. Landing gear extended for what should have been a routine wheels-down landing. Then disaster struck. Shikada, flying overhead, suddenly noticed water glistening between the grass stalks on his second pass. He realized with horror that the field was actually a bog. The grass was concealing knee-deep mud and standing water. He tried to radio a warning, but it was too late. Koga was already committed to his landing. The Zero's wheels touched the grass at approximately 80 miles per hour. For a brief moment, the landing seemed successful. Then the main gear sank into the soft mud beneath the vegetation, catching with tremendous force. The lightweight fighter flipped completely over in a violent cartwheel. The aircraft slammed upside down into the bog with bone-crushing impact. The force snapped Koga's neck instantly, killing him before he could draw another breath. Above, Koga's wingmen faced an agonizing decision. Standing orders required them to destroy any disabled Zero, to prevent it from falling into enemy hands. They circled the crash site multiple times, machine guns ready, looking for any sign that their comrade had survived. The aircraft appeared so intact, sitting upside down in the marsh like a turtle on its back, that they could not bring themselves to fire. Perhaps Koga was alive, or trapped, waiting for rescue. They could not murder their friend on the chance he might survive. After several more passes, their fuel running low, they reluctantly turned west and returned to the Aleutian. Koga's body and his Zero remained alone in the Aleutian wilderness, 5,000 miles from Japan, waiting to betray every secret of the Empire's most feared weapon. For 5 weeks, Koga's Zero sat undisturbed in the Akutan bog. The crash site lay out of sight of standard shipping lanes and aerial patrol routes, hidden in a small valley that received perhaps 6 days of clear visibility per month through the perpetual Aleutian fog. Then on July 10th, 1942, fortune intervened. An American PBY Catalina patrol bomber piloted by Lieutenant William Thiers became lost. Navigation in the Aleutians was treacherous, with magnetic compasses unreliable near the Arctic Circle and landmarks obscured by near-constant fog. Thiers had been navigating by dead reckoning when he spotted the Shumagin Islands through a break in the clouds. Recognizing his position, he corrected course for Dutch Harbor, choosing to fly directly over Akutan Island, rather than around it to save time and fuel. Much and his mate, Albert Knack, serving as plane captain, happened to glance down at precisely the right moment. Through a temporary gap in the fog, he spotted an unusual shape in the marsh below. The bright red circles on the wings were unmistakable. Thiers circled the site several times, noting the position carefully on his charts. The Zero appeared remarkably intact, a prize beyond imagination. He immediately returned to Dutch Harbor to report the discovery. Within hours, a recovery party landed near the crash site. What they found exceeded their wildest hopes. The Zero had landed in perhaps the only spot on Akutan Island where the bog was soft enough to cushion the impact while being firm enough to prevent the aircraft from sinking. The marsh had acted like a giant shock absorber. Aside from a crushed windscreen, bent propeller tips, broken landing gear, and damaged wingtips, the aircraft was fundamentally intact. The recovery team carefully removed Koga's body from the cockpit and buried him with military honors on a hillside overlooking the crash site. They noted the extensive medical taping around his torso, suggesting previous injuries or precautionary measures against high G-force maneuvers. His personal effects, including his pistol and sword, were removed as intelligence materials. Then began the challenging task of extracting a fighter aircraft from an Aleutian bog. The recovery operation took nearly 3 weeks of backbreaking labor in some of the most inhospitable conditions on Earth. Workers constructed a makeshift road using logs and planking, slowly winching the captured fighter across half a mile of treacherous ground to Broad Bight, where it could be loaded onto a barge. By late July, the Zero had been loaded aboard a cargo ship for transport to the United States. The captured Zero arrived in Seattle on August 1, 1942, then was transferred immediately to a barge for the journey to Naval Air Station North Island near San Diego. The aircraft reached San Diego in mid-August, where it was unloaded under heavy guard and moved to a secure hangar. 24-hour military police protection ensured no souvenir hunters could damage the invaluable prize. Word of the capture spread through Navy aviation circles with electric excitement. For the first time since the Zero's devastating debut at Pearl Harbor, American engineers and pilots would have the opportunity to examine the legendary fighter in detail. Navy Captain William Leonard, who would later command a carrier division in the Pacific, called it a treasure that unlocked so many secrets at a time when the need was so great. The race was on to restore the Zero to flying condition as quickly as possible. Every day the aircraft remained grounded was another day American pilots faced an enemy they did not fully understand. The restoration team worked around the clock, carefully documenting every detail of the aircraft's construction, while simultaneously repairing the crash damage. The restoration revealed immediate insights into Japanese design philosophy. The Zero was built like a precision watch, one engineer noted, with flush rivets throughout the airframe and guns mounted flush with the wing surfaces to minimize drag. Every component was designed for minimum weight and maximum efficiency. The instrument panel displayed remarkable simplicity, with no superfluities to distract the pilot. Just essential gauges arranged for instant readability. Inspection panels could be opened by simply pushing on marked spots with a finger, releasing internal latches. The entire aircraft could be disassembled and reassembled using minimal tools, a crucial advantage for the field maintenance on primitive island bases. The team discovered that the Zero weighed between 5,300 and 6,165 pounds fully loaded, depending on ammunition, fuel load, and configuration. That was roughly 2,000 pounds lighter than the American F6F Wildcat. This extraordinary weight savings came from multiple sources. The Zero lacked armor protection for the pilot, relying instead on superior maneuverability to avoid being hit. The fuel tanks were not self-sealing, trading safety for reduced weight and increased capacity. The airframe itself used minimum structural material, just enough strength for the anticipated loads with no safety margin. The Zero was fundamentally a different design philosophy than American fighters, where American aircraft prioritized pilot protection and structural ruggedness, accepting weight penalties for survivability. The Zero sacrificed protection for performance. It was a fighter designed to win through superior agility, rather than absorbing punishment. The captured aircraft revealed other secrets. The engine, a 14-cylinder Nakajima Sakai radial, producing approximately 950 horsepower, used a float-type carburetor that would prove significant in combat. The wings folded for carrier storage using a simple manual mechanism requiring no hydraulic systems. Most remarkably, the armament package was formidable for such a lightweight aircraft. Two 7.7-meter machine guns firing through the propeller arc and two 20-millimeter cannons mounted in the wings. By September 20th, just 41 days after arriving in San Diego, the Zero was ready to fly. The restoration team had replaced the crushed windscreen, straightened the vertical stabilizer and rudder, repaired the wing tips and flaps, and completely rebuilt the landing gear. The captured aircraft was repainted with the red Japanese Hinamaru roundels, covered with American blue circle and white star insignia. Lieutenant Commander Eddie Sanders, selected as chief test pilot for the project, had spent the previous week studying every aspect of the Zero, while mechanics completed the restoration. He sat in the cockpit for hours, familiarizing himself with the Japanese instruments, memorizing the control layout, preparing mentally for a flight unlike any he had attempted. Sanders was an experienced test pilot, but he was about to fly an enemy aircraft whose flight characteristics could only be guessed from intelligence reports and combat observations. If those reports were accurate, the Zero was faster, climbed better, and turned tighter than any American fighter. If the captured aircraft had hidden damage, Sanders might not survive the first flight. On the morning of September 20th, 1942, Sanders climbed into the Zero's cockpit for the first time as pilot rather than student. Ground crew started the engine, which caught immediately and ran smoothly. Sanders taxied to the runway, conscious that dozens of engineers, intelligence officers, and Navy brass were watching from the tower and flight line. He advanced the throttle, and the Zero accelerated down the runway with surprising eagerness. The lightweight fighter lifted off after a remarkably short ground roll, climbing at a rate that would have been impressive in any American aircraft. For the next hour, Sanders put the Zero through a series of performance tests, carefully exploring its flight envelope. He climbed to altitude, tested stall characteristics, practiced basic maneuvers, and felt out the aircraft's handling qualities. What he discovered in that first flight would change everything. Immediately apparent was the fact that the ailerons froze up at speeds above 200 knots, making rolling maneuvers at those speeds slow and requiring much force on the control stick. Sanders wrote in his report that the Zero rolled to the left much easier than to the right. The high-speed aileron problem was dramatic and unexpected. At low speeds, the Zero's maneuverability was everything Japanese pilots claimed, capable of turning inside any American fighter with ease. But above 200 knots, roughly 230 miles per hour, the ailerons became increasingly heavy and unresponsive. The fabric-covered control surfaces ballooned with air pressure at high speeds, requiring enormous stick force to overcome. American fighters, with their metal-covered control surfaces and hydraulic boost systems, maintained full control authority at all speeds. Sanders discovered a second critical weakness during negative acceleration maneuvers. When he pushed the stick forward sharply, inducing negative gravitational forces, the Zero's engine coughed and died. The float-type carburetor, designed for positive and zero-gravity conditions, could not maintain fuel flow during sustained negative acceleration. The engine would restart when positive acceleration resumed, but for several seconds, the Zero became a powerless glider. This weakness had profound tactical implications that Sanders recognized immediately. He noted in his report, "Go into a vertical power dive using negative acceleration if possible, to open the range while the Zero's engine was stopped by the forces involved. At about 200 knots, roll hard, right before the Zero pilot could get his sights lined up." Sanders completed 24 test flights over the next 25 days, each one revealing additional details about the Zero's capabilities and limitations. He tested the aircraft at various altitudes, power settings, and combat configurations. He performed mock dogfights against American fighters with other test pilots flying F4F Wildcats and newer aircraft. The data accumulated from these flights was extraordinary. The Zero's maximum speed was slightly less than the F4F Wildcat, contrary to combat reports suggesting the Japanese fighter was faster. However, the Zero's exceptional range, over 1,900 statute miles, far exceeded any American carrier fighter. The aircraft could remain airborne for over 6 hours, enabling it to escort bombers deep into enemy territory or patrol vast expanses of ocean. The Zero's rate of climb exceeded American fighters significantly, capable of reaching 20,000 feet faster than an F4F could reach 15,000 feet. In turning combat at low speeds, the Zero could complete a full circle in the time American fighters could complete only 3/4 of a turn. These performance characteristics explained why early war combat had favored Japanese pilots so decisively. At low speeds and in turning fights, the Zero was simply superior to anything America fielded in late 1941 and early 1942. But Sanders' tests revealed that these advantages came with exploitable weaknesses. The Zero's light construction meant it could not withstand battle damage. Hits that would merely damage an American fighter often proved fatal to the Zero, which lacked armor and self-sealing fuel tanks. Sanders' final report synthesized all the test data into actionable intelligence. American pilots should avoid slow-speed turning fights where the Zero's maneuverability dominated. Instead, they should use diving attacks, utilizing the superior high-speed characteristics of American fighters. When a Zero pursued, American pilots should enter a steep dive, preferably with negative acceleration to kill the Zero's engine, then execute a hard right roll at high speed where the Zero could not follow. American fighters should use their superior armor and firepower to absorb hits while delivering devastating bursts that would destroy the fragile Zero. Team tactics should replace individual dogfighting, with wingmen covering each other and using coordinated attacks to negate the Zero's turning advantage. These recommendations were compiled and distributed throughout the fleet with unprecedented speed. Pilots preparing for combat received detailed briefings on the Zero's characteristics and how to exploit its weaknesses. The information was incorporated into training programs, with instructors teaching the high-speed dive and hard right roll technique to every new pilot. Combat veterans who had survived early encounters with Zeros suddenly understood what they had been fighting and how to win. The impact on pilot morale was profound. For 8 months, American naval aviators had faced an aircraft that seemed invincible, capable of outturning and outclimbing anything they flew. Pilots had developed a healthy respect for the Zero that bordered on fear. Now, for the first time, American pilots had concrete knowledge of how to fight the Zero and win. The mystique surrounding the Japanese fighter began to crumble. It was still a formidable opponent, but it was no longer invincible. It had weaknesses, and American pilots now knew exactly what those weaknesses were and how to exploit them. But the Akutan Zero's greatest contribution was not to tactical doctrine. It was to aircraft design, specifically to a fighter that was already under development when Koga crashed in the Aleutians. The Grumman F6F Hellcat would become the weapon that transformed American tactical knowledge into devastating combat results. January 1942. Grumman Aircraft Engineering Corporation, Bethpage, Long Island, New York. Leroy Grumman sat at his desk, reviewing preliminary designs for what would become the F6F Hellcat, and the numbers troubled him. The Navy needed a fighter to replace the F4F Wildcat, something faster and more powerful to counter the reports coming from the Pacific about Japanese air superiority. The early months of 1942 brought increasingly alarming reports from the Pacific. American pilots were being outfought by Japanese Zeros at every encounter. The F4F Wildcat was proving inadequate despite being a solid, well-built aircraft. Combat reports indicated the Zero could outclimb, outturn, and outrange the Wildcat in nearly every performance category. Something dramatically better was needed, and needed urgently. On April 22, 1942, 6 weeks before the Battle of Midway and 7 weeks before Koga's crash, Lieutenant Commander Edward Butch O'Hare visited Grumman's Bethpage facility. O'Hare, fresh from combat operations in which he had single-handedly defended the carrier Lexington against Japanese bombers, earning the Medal of Honor, met with Grumman engineers to discuss the F4F Wildcat's performance against the Zero. His insights were sobering. The Zero was faster than American intelligence had estimated, climbed better than seemed physically possible for its engine power, and could turn inside the Wildcat with ease. O'Hare emphasized that American fighters needed more power, better climb rate, and improved visibility for the pilot. The day before meeting with Grumman engineers, O'Hare had met with President Franklin Roosevelt during the Medal of Honor presentation ceremony. The president asked what was needed in a new naval fighter. O'Hare's response was direct and memorable: a plane that will go upstairs faster. On April 26, 1942, 5 weeks before Koga's final flight, the Bureau of Aeronautics made a critical decision that would define the F6F's character. Based on combat accounts from the Pacific and O'Hare's recommendations, the Bureau directed Grumman to install a more powerful engine in the second prototype. The Wright R2600 was abandoned in favor of the Pratt & Whitney R2800 Double Wasp, an 18-cylinder radial engine producing 2,000 horsepower. This was the same engine being used in the Vought F4U Corsair and Republic P-47 Thunderbolt, and it represented a 50% increase in power over the original design. The engine change decision came before the Akutan Zero was even discovered. The first prototype made its maiden flight on June 26, 1942, 8 days before Koga crashed in the Aleutians. The second prototype, fitted with the 2,000 horsepower R2800 Double Wasp, first flew on July 30, 1942. This was 20 days after the Akutan Zero was discovered, but 2 months before it would be restored to flying condition and tested. Throughout the summer of 1942, Grumman engineers continued refining the design based on ongoing combat reports and intelligence from the Pacific. When the Akutan Zero arrived in San Diego in mid-August, detailed technical data began flowing to the Bureau of Aeronautics and Grumman within days. The captured aircraft had not yet flown, but physical examination revealed crucial information about its construction, weight, armament, and design philosophy. This intelligence arrived at a critical moment in the F6F's development. The basic design was set, the engine selected, and the first prototypes flying, but production had not yet begun, meaning changes could still be incorporated relatively easily. The Zero weighed between 5,300 and 6,100 pounds fully loaded. The F6F would weigh over 12,000 pounds. This enormous weight penalty, more than double the Zero's weight, had to be compensated by additional power and intelligent design. Grumman's philosophy differed fundamentally from the Japanese approach. Where the Zero sacrificed protection for performance, the F6F would provide both. Roy Grumman, the company's founder, made a key decision after studying the Zero data. He determined that Grumman could match or surpass the Zero in most respects without sacrificing pilot armor, self-sealing fuel tanks, and robust fuselage structure. The data from the Akutan Zero, combined with combat reports and Sanders' test flights in September and October, influenced specific design decisions as the F6F moved toward production. F6F's wings were designed for high-speed performance using a different airfoil and control surface design than the Wildcat. The ailerons were hydraulically boosted and metal-covered, ensuring full control authority at all speeds. This directly addressed the high-speed aileron problems Sanders discovered in the captured Zero. The F6F would be able to roll effectively at speeds where the Zero's controls locked up. The F6F's fuel system used a pressure carburetor rather than the float type used in the Zero. This ensured the engine would continue running under negative acceleration, eliminating the weakness Sanders had exploited in his test flights. An F6F pilot could dive away from a pursuing Zero without his engine quitting at the crucial moment. The armament package was increased to 650 caliber machine guns compared to the Wildcat's 4. The concentrated firepower could destroy the lightly built Zero with short bursts, while the F6F's armored structure could absorb return fire. Visibility from the cockpit was exceptional, with the raised pilot position providing clear views in all directions. This addressed the emphasis that pilots could not shoot what they could not see. On October 3, 1942, the first production F6F-3 made its maiden flight, just 2 weeks after Sanders completed his initial test flights in the Akutan Zero. The timing was not coincidental. Production had been deliberately delayed until engineers could incorporate the latest intelligence. The first production F6F-3s began reaching fleet squadrons in early 1943. Fighting Squadron 9 received the first operational Hellcats in February 1943, embarking on the carrier Essex for training and workup. The pilot's reaction to the new fighter was enthusiastic. After months of fighting in F4F Wildcats, struggling against superior Japanese aircraft, the F6F felt like a quantum leap in capability. Production ramped up with astonishing speed. Grumman built a new factory at Bethpage specifically for F6F production. At peak production in 1944, Grumman produced 644 aircraft in a single month, 1 Hellcat per hour. Between the first production flight in October 1942 and the end of the war in November 1945, a span of approximately 37 months, Grumman would produce 12,275 F6F Hellcats from a single factory complex. The F6F made its combat debut on August 31, 1943, 15 months after the Akutan Zero was discovered and 11 months after Sanders' first test flight. Aircraft from fighting squadrons 5 and 9, operating from carriers Yorktown and Independence, attacked Marcus Island as part of a carrier raid. The mission was an overwhelming success. Over the following months, the F6F became the standard fighter on American fleet carriers. The tactical lessons learned from the Akutan Zero were incorporated into every aspect of F6F operations. Pilots were trained to avoid slow-speed turning fights unless they had significant altitude or numbers advantage. Instead, F6F doctrine emphasized high-speed slashing attacks, diving from altitude to build speed, making a single firing pass, then zooming back to altitude before the more maneuverable Zeros could respond. November 23, 1943, Gilbert Islands. F6F Hellcats from carrier Essex engaged Japanese Zero fighters over Tarawa in what would become the first major test of the new fighter against Japan's best. 30 Zeros rose to intercept the American strike, and the ensuing dogfight raged across the skies over the invasion beaches. When the smoke cleared, American pilots claimed 30 Japanese fighters destroyed for the loss of a single F6F. The Battle of Tarawa demonstrated everything the F6F was designed to accomplish. American pilots, many of them relatively inexperienced, had met veteran Japanese aviators flying Zeros and crushed them utterly. The combination of superior aircraft performance, sound tactics based on knowledge of the Zero's weaknesses, and intensive training had created an unbeatable formula. But Tarawa was just the beginning. The F6F would prove its worth in every major engagement across the Pacific for the next 20 months, compiling the most dominant combat record of any American fighter in world. War II, June 19, 1944. Philippine Sea, west of the Mariana Islands. F6F Hellcats from 15 American aircraft carriers prepared to face the largest Japanese carrier aviation force assembled since the Battle of Midway 2 years earlier. What followed became known as the Great Marianas Turkey Shoot, the most one-sided aerial battle in naval history. The first Japanese strike, 69 aircraft, lost 42 planes before reaching the American fleet. The second wave, 107 Japanese aircraft, lost 97 before they could even attack. Throughout the day, Japanese carriers launched 370 aircraft in multiple strikes. Only 130 returned. The F6F Hellcats, flying combat air patrol over the American fleet and hunting Japanese strike groups, shot down the vast majority. American losses totaled 23 to 30 aircraft, with many pilots rescued from the ocean. The strategic impact was catastrophic for Japan. Japanese naval aviation would never recover from this single day's losses. By the end of World War II, F6F Hellcats had compiled statistics that remain unmatched by any other American fighter. The aircraft was credited with destroying 5,163 enemy aircraft in Pacific air-to-air combat by United States Navy and Marine Corps pilots. Only 270 F6Fs were lost in air-to-air combat, giving the aircraft an overall kill-to-loss ratio of 19-1. Against Japanese Zeros specifically, the ratio was 13-1. The F6F produced more fighter aces than any others. Allied aircraft of World War II. Between 305 and 307 Navy Hellcat pilots achieved ace status with 5 or more victories. The Navy's top ace, Commander David McCampbell, scored all 34 of his victories flying F6Fs, the Hellcats. Combat record was so dominant that late-war Japanese pilots developed what American intelligence called zero fatigue, recognition that engaging F6Fs was likely to be fatal. Japanese pilots increasingly avoided combat when possible, diving away or fleeing into clouds rather than fighting. The contrast with early war combat was stark. In 1942, American pilots had fled from Zeros whenever possible. By 1945, Japanese pilots were fleeing from Hellcats. The transformation was complete. The Akutan Zero's role in this transformation cannot be precisely quantified, but its importance is undeniable. The captured aircraft provided the first detailed intelligence on the Zero's capabilities and limitations. Sanders' test flights revealed specific weaknesses that could be exploited tactically. The technical data influenced F6F design decisions at a crucial moment when changes could still be incorporated. Most importantly, the Akutan Zero destroyed the mystique surrounding the Japanese fighter, proving it was not invincible, but rather an aircraft with specific strengths and specific weaknesses. The Akutan Zero was destroyed in February 1945, ironically in a training accident rather than combat. While taxiing for takeoff at Naval Air Station North Island, an SB-2C Helldiver dive bomber lost control and crashed into the parked Zero, its propeller slicing the Japanese fighter into pieces. The physical aircraft was gone, but its legacy lived on in every F6F that flew combat missions, in every American pilot who knew the Zero's weaknesses, in every tactical manual that incorporated lessons learned from Sanders' test flights. Koga's body, initially buried on Akutan Island, was exhumed by American Graves Registration Service teams in 1947, and reburied on Adak Island, further down the Aleutian chain. In 1953, the Adak Cemetery was excavated, and 236 bodies, likely including Koga's remains, were returned to Japan for burial. The young pilot, who died at age 19, became an unwitting contributor to Japan's defeat, his perfectly preserved aircraft revealing secrets that would doom thousands of his countrymen. Japanese historian and Air Self-Defense Force Lieutenant General Masatake Okumiya, who flew as a staff officer in most major Pacific carrier battles, stated that the acquisition of the Akutan Zero was no less serious than the Japanese defeat at Midway. The Zero's secrets being revealed to American engineers and test pilots represented a catastrophic intelligence failure whose consequences rippled throughout the remaining war years. Fighter ace William Leonard called the captured Zero a treasure that unlocked so many secrets at a time when the need was so great. Marine ace Kenneth Walsh credited intelligence from Koga's Zero with saving his life several times, the tactical knowledge allowing him to survive early encounters that might otherwise have been fatal. The Akutan Zero was not solely responsible for American victory, which rested on industrial capacity, code-breaking, submarine warfare, and numerous other factors. But it was a crucial piece of the puzzle, arriving at exactly the right moment to influence aircraft design decisions and tactical doctrine development. Without the Akutan Zero, the F6F would still have been an excellent fighter. American industry would still have overwhelmed Japan's production, and American victory would likely have been achieved. But the process might have taken longer, cost more American lives, and involved greater uncertainty about how to defeat the Zero's capabilities. The 19-to-1 kill ratio represented the culmination of multiple factors converging perfectly. Superior aircraft design that prioritized both performance and pilot protection. Tactical doctrine derived from studying the enemy's capabilities and weaknesses. Training that prepared pilots for the realities of combat. Industrial production that ensured numerical superiority. And crucially, detailed intelligence about the enemy's primary weapon gained from a single, nearly intact example captured by chance in the Aleutian wilderness. Veterans who flew F6F Hellcats during the war consistently emphasized a common theme when recalling their experiences. "We were told the Zero was invincible," one former fighter ace explained. "We believed it because we had seen what it could do to our aircraft in early combat. Then we learned its secrets from the captured plane in Alaska. We learned it could not roll at high speed. We learned its engine quit under negative acceleration. We learned it was fragile and would burn if hit. And suddenly it was no longer invincible. It was just another aircraft, one we could beat if we flew smart. The F6F gave us the tools. The Akutan Zero gave us the knowledge. Together they gave us victory." The F6F Hellcat remained in frontline service through the end of World War II, gradually being supplemented by the F4U Corsair. After the war, Hellcats were quickly phased out of fleet service, replaced by jets and more modern propeller fighters. The last Navy Hellcat was retired in 1954, just 9 years after the war ended. But the Hellcat's combat record ensured it would never be forgotten. Approximately 70 F6F Hellcats survive in museums and private collections worldwide. 7 remain airworthy, all based in the United States, regularly flown at air shows and commemorative events. Each flight is a reminder of the 12,000 aircraft that rolled off Grumman's assembly lines, the 34,000 pilots who flew them in combat, and the 5,000 enemy aircraft they destroyed. The broader lesson from the Akutan Zero and F6F Hellcat story extends beyond World War II. Modern military forces spend billions on intelligence gathering, technical analysis, and threat assessment because the Akutan Zero example proved how valuable detailed knowledge of enemy capabilities can be. Understanding your enemy's capabilities and limitations can mean the difference between victory and defeat. A single piece of hardware, properly analyzed and exploited, can influence the design of weapon systems, the development of tactics, and the outcome of battles. The Akutan Zero arrived at precisely the moment when it could influence F6F development. Sanders's test flights revealed weaknesses at exactly the time when pilots needed confidence to face the Zero. The tactical lessons were distributed when training programs could incorporate them. A year earlier or later, the impact might have been minimal. The timing was perfect, and America exploited it fully. The young Japanese pilot who died in an Aleutian bog could not have known that his perfectly preserved fighter would contribute to his nation's defeat. His wingmen, hoping he survived, could not have known that their mercy in not destroying his aircraft would doom thousands of their comrades. The American salvage crews struggling in that Alaskan marsh could not have known they were recovering the key to air superiority in the Pacific. And Eddie Sanders, taxiing that captured Zero for its first American flight, could not have fully appreciated that his test flights would influence a fighter that would help win the war. But history is made by such moments, when chance and preparation intersect, when fortune favors those ready to exploit it, when a single piece of intelligence arrives at exactly the right time to influence events far beyond its apparent significance. The Akutan Zero was such a moment, and the F6F Hellcat was its legacy. One captured aircraft, one skilled test pilot, one moment in time when intelligence, design and tactical doctrine converged to create a weapon system that achieved a 19-to-1 kill ratio and swept Japanese aviation from Pacific skies. The story of how one test pilot's captured Zero turned the F6F Hellcat into a 19-to-1 killing machine demonstrates that warfare is decided not just by courage and firepower, but by intelligence, adaptation, and the ability to learn from the enemy. The F6F Hellcat and the Akutan Zero together wrote a chapter in aviation history that continues to resonate 8 decades later. Proof that sometimes the greatest victories come not through destruction, but through understanding.